Hi guys, in this problem, this is the second of three videos, or three videos today, maybe four, I don't really know, on how to solve exponential equation problems. The difference in this video is last time we saw that the thing with the exponent was already by itself. Here I've got 9 to the x power, but then I've got minus 3. And so before I go any farther, really the only thing I want to point out is I've got to get that 3 over and away from the exponent first, which means I've got to add it to both sides. And so my first step in this problem, well, it's not 9x, it's 9 raised to the x. I'm going to add 3 to both sides, and that gives me 52 on the right-hand side. Okay, I know that's a pretty simple example here, but I just want you to see that before I can go through and do all the stuff that I did in the last video with the change of base formula and the log base 3, or in this case log base 9, that I've got to get the exponent by itself. So now that I have this, I'm going to do log base 9 of both sides. I'm choosing that, 9 to the x. I'm choosing log base 9 because that's the base of the equation. Okay, if you choose the wrong number, it's obviously going to give you something different over here. Log base 9 of 9 goes away, and I'm left with just x. And x is equal to the log of 52 divided by the log of 9 using the change of base formula. So on my calculator, I'm going to do log of 52 in the parenthesis divided by log of 9 in the parenthesis. It's 1.7982, which means I can keep it as 1.798. 1.798 is our answer. Okay, how about in this one? Before I go any farther, I have to get the 18 to the 6x. See, the 5 isn't being raised to the power. The only thing being raised to the power is the 18. So my first step is divide both sides by the 5, okay? And when I do that, the 5's go away, and I have 26 divided by 5 on the right-hand side. 18 to the 6x power is equal to 26 fifths. Okay? Now, I'm going to do log base 18 of both sides. I'm choosing 18 once again because that's the base of the exponent. Log base 18 of 26 fifths. This is getting messy, right? But it's all right. Okay? And when I do that, that's going to cross out all this stuff, and it's going to leave me not with an x this time. Here's another twist. It leaves me with the 6x, right? It leaves me with the exponent. So 6x is equal to log of 26 fifths divided by the log of 18 using the change of base formula, right? So what I'm going to do is I've got to do this just one piece at a time. I'm going to type in the log of 26 over 5 divided by the log of 18. I'm going to hit enter, and that's going to tell me what 6x is equal to. And then I'm going to have to take that answer, I'm going to have to divide by 6, and that's going to tell me what a single x is equal to, right? So this is going to be kind of a two-step problem to solve from here on out. So here we go. Ready? Log of 26 fifths divided by the log, the log of 18. Make sure you end your parentheses there after the 26 fifths, right? So that's what 6x is. It's 0.570396 or something, 0.570396, ... keeps going on, right? I'm going to take this answer, I'm going to divide it by 6. That gives me what a single x is. It's 0.095. Okay, so hopefully that makes sense. That's a little bit of a twist. I've got one more video I want to show you that's specifically related to this problem. What if I get 2 to a power and 3 to a power, and which one do I raise it to? Do I do log 2 or log 3 or what? Okay, you know what? Heck, let's just do it now. There we go. Ready? Finished off. You get a problem like this. Your best bet is just to do the natural log of both sides. Okay, so I'm going to do the natural log of 2 raised to the 3x plus 1 is equal to the natural log of 3 raised to the x minus 2. Okay? You could do log as well. It's fine. It's going to give you the same thing in the end. All right, now, using my properties of exponents and properties of logarithms, I know that I can take this and I can rewrite it out in front. So I'm going to take the exponent here. I'm just going to drop it out in front. I'm going to take this exponent here, and I'm going to drop it out in front. So in other words, I'm going to get 3x plus 1, notice I use parentheses, times the natural log of 2, is equal to x minus 2 times the natural log of 3. We're getting closer. Next step, this is a complicated problem. Next step is distribute out the 3x and the 1 to the natural log of 2. So I'm going to have 3x times the natural log of 2 plus 1 times the natural log of 2, which is just natural log of 2. On the right-hand side, I have x times the natural log of 3 minus 2 times the natural log of 3. Okay, now notice as I look at this, I have an x here and I have an x here, but I don't have x's over here in these two, right? So I'm going to take all the things with the x's and we're going to put them on the left-hand side together. I'm going to take all the things without x's and I'm going to put them on the right-hand side, on the opposite side of the equal sign. So that means then that I have 3x times the natural log of 2, and I'm going to subtract the x natural log of 3 from the right-hand side, from both sides. Subtract it over. That's equal to, and then I have the negative 2 natural log of 3 on the right, and I'm going to subtract this natural log of 2 away from the left and put it over on the right. So notice all I did is I took the natural log of 2 and I moved it to the right. I took the thing with the x and I moved it over to the left by subtracting from both sides. Now you'll notice that I have 3x natural log of 2 minus x natural log of 3. I have an x in both terms, right? So I'm going to take an x and I'm going to factor it out. If I take the x and I factor it out, that leaves me with 3 natural logs of 2 here minus the natural log of 3 here. So it's a factoring problem, right? Pull out the x. On the right-hand side, I'm just going to rewrite negative 2 natural log of 3 minus natural log of 2. And now what I can do is if I have x times this chunk of stuff is equal to the stuff on the right, then I can divide by the chunk. Let's divide both sides by the same thing. We'll divide it by 3 natural log of 2 minus natural log of 3. 3 natural log of 2 minus natural log of 3. Because that takes this and puts it away. Okay, moves it away. So we're getting darn close here. All I need to do is I need to go through and I need to type all this stuff in my calculator and figure out what it equals. Okay, be careful about parentheses. So here we go. I have negative 2 natural log of 3 in the parentheses. I'm going to subtract the natural log of 2 in the parentheses. So that's what the top is. It's negative 2.89037, right? Negative 2.89037, okay? I'm not going to take this out of my calculator. I don't really want to type all that stuff in again, okay? So I'm just going to divide by, and I'm going to use parentheses to group the denominator together. 3 natural logs of 2 in the natural log. Only one end of the parentheses, though, because I still want to keep this one for the denominator. Minus the natural log of 3 in the natural log, and now in the denominator. Okay, so you see that? I got a group of parentheses here for the 2, a group of parentheses here for the natural log of 3, and then I have a third group of parentheses for the denominators to group it all together. And when I type that in, it's negative 2.9468, so it looks like 2.947. I'm going to round up to 7 for the third decimal. X is negative 2.947. Now that is a complicated problem, folks, okay? You're getting up into college algebra type stuff there. I don't know if I'll ask you that on the test. If I do, that'll be one of the more difficult questions on the test. But hopefully the process makes a little bit of sense to you. I think that the problem really is going to be the distributing and remembering all these little steps that we had to do here and how to factor out the x, okay? Okay, you know what? Forget it. I know this is a long video, but let's just do this last example as part of this video because it would only be a 30-second video otherwise. Don't forget, if I ever get something that just looks ridiculously complicated. And this rule actually goes, guys, if we're taking a multiple choice test, I don't care how you get the answer, okay? I need you to get the answer. And so, even on any of these, you can always go graph. Left side is y1, right side is y2. So don't forget that you can always go like this and you can say, you know what, I'm going to type that in as y1, I'm going to type this as y2, and that's going to form a couple of lines, and I'm looking for where they cross, okay? So on my calculator, I could easily type in e raised to the x squared. That ends the exponent, notice, minus 2, so that negative 2 is off by itself, right? The minus 2 is off by itself. And the right-hand side is x cubed minus x, so I simply just need to type in x to the third minus x. I'm going to graph these. There's the x, e to the x squared minus 2. Ooh, look at this. That might even cross 3 times. I really don't know. So I'm going to zoom in a little bit. Okay, I'm going to use the box feature, zoom box feature. I'm going to go over here and I'm going to say, okay, I hit enter there on the bottom left corner. I drag over and I drag up, and I'm going to hit enter in here. It's going to zoom in. There's the first one, e to the x squared minus 2. 1, 2, 2 times it meets. The two locations are, second, calculate. Find out where they intersect. The two locations where they meet are Okay, that's pretty close. I'm going to hit enter, enter, enter 3 times in a row. Negative 0.886, it looks like, if I'm rounding to 3 decimals because it's 5/6. And I'm going to repeat the process. Second, calculate. Option 5 is intersect. I'm going to scroll over here to the right-hand side. Enter, enter, enter. 0.706. So just remember, you can always go through and graph in order to solve and at least have the answers there so you can get the answer correct on, say, an end-of-course exam or an ACT test or something like that. All right, guys, so I apologize. That ended up being a much longer video than expected. I should have probably split that up into multiple small videos. But that walks you through the homework for today, and we're going to practice mainly problems like numbers 1, 2, 3, and 4, and 5, okay? Number 6 may or may not show up on a test. If it does, it'll be one of the more difficult ones. And this, you know what, that's just a good skill to have, to know that you can graph 2 lines and find out where they intersect in order to solve for x. That's just a nice thing to know how to do. All right, I'll see you in the classroom.